Hi. Well, for today, I will speak about a manual or a standard test method for Marshal stability and flow of asphalt mixtures. Well, I start this podcast with the significance and use of this method. It is a manual. It's a manual when we've found some indication how we use some materials or some methods to do in laboratories about in engineering about in constructions. In this case, this part which show us the standardization about the method Marshall, like stability Marshall and flow Marshall. We compare with these values with the density the and air voids in the total mix, void of minerals aggregate, about the voids filled with the asphalt. With these values, we can compare or we found the process of produce the mixed asphalt in the plant of asphalt. We use these values to compare two or three mixed difference with different size of aggregates and compare in many other conditions, such as, or for example, the content of water in this mixed. To do in the laboratory the Marshall stability and flow, we can use two methods. The method is about a loading frame in the package of mix, a little package can we use in the laboratory, and the method B is using load deforming. It is a new method can we use, but in Peru we aren't the machines, the equipment to do this kind of methods. Once we do in the laboratory, we release the design of mix of this mixture, and we put this mixture to evaluate in this equips and these machines. We obtain some results. The results, for example, is the stability versus deformation and stability versus fluence or flow. For example, the moisture, the normal moisture in the first minutes of this mixture is a linear equation and we the load is more times over this moist over this sample. We obtain an equation. I think this is a linear equation, but after the fillet of this moisture, the equation is parabolic equation, but we need the result only in the in the linear equation, but after this the moisture is filed and the test is finished. We we take off the moisture, the sample, and we continue with the two moisture two. Well, we need three kinds of samples to release a good design. But it's three kinds of sample per percent of asphalt we use. For example, normally in the laboratory we use first 2% with the aggregate. The aggregate or the weight of aggregate is a constant, never change. Once we we test the aggregate like test of safe long size physical characteristic about these materials, and we play and we guess the optimus of this of content of asphalt in the mixture. We start with 2%, 4%, 6%, and 70%. Why we take this percent of asphalt? We take this range of percent of asphalt because the normal the standardization of the designs of mixed asphalt is normally to 5% and 7% with maximum value, and we release some graphics to compare, and we obtained the optimus content of asphalt, and this is our primary design to control in the file. For example, we control this percent of aggregates of asphalt, of filler, of mineral-free filler, of additive in the plant of asphalt. When the we don't more candidates of mixtures, and we comprove this percent um, again in the laboratory, and finally we can put over over the base in the way, and we after this we control it the the machines. For example, the compactations, the homogenization about the collocation of um, of the mixture in the field. Finally, I think it's important the work in the laboratory, because with this result, we can control the quality of the job, of the final mix, the life of duration or life of service to the users. Well, I continue with this standard reading itself. Standard test methods for Marshal stability and flow as asphalt mixture. Like code, it has D 6925-15. This is the code of this title of this standardization. In the significance and use, it says Marshal stability and flow value along with density, air voids in the total mix, void in the mineral aggregates, or void filled with asphalt, or both. Filled with asphalt are used for laboratory mix design and evaluation of asphalt mixtures. In addition, Marshal stability and flow can be used to monitor the plant process of producing asphalt mixture. Marshal stabilization and flow may also be used to reliability evaluate different mix and the effect of conditions such as with water. Marshal stability and flow are asphalt mixture characteristics determined from tests of compacted specimens of a specified geometry. The Marshal test can be conducted with two different types of equipment, like first, method A, using loading frame with a load ring and dial gauge for the formation of flow measure. It is the traditional method. Or second, method B, using load deformation recorder in conjunction with the load cell and linear variable differential transducer. Also called LBDT, or other automatic record device automate method. Typically, Marshal stability in the peak resistance load obtained during the constant rate of the formation loading sequence. However, depending on the composition and behavior of the mixture, a less defined kind of failure has been observed, as illustrated in Figure 1. As an alternative method, Marshal stability can also be defined as the load obtained when the rate of loading increase begin to decrease, such that the curve starts to become horizontal, as shown in the bottom graph of Figure 1. The magnitude of Marshal stability varies with aggregate type and grading and bitumen type. rate, and amount. Various agencies have a criteria for Marshall stability. Marshall flow is a measure of deformation, elastic plus plastic, of the asphalt mix determined during the stability test. In both types of failure, the Marshall flow in total sample deformation for point where the project a tangent of linear part of the curve intersect that a x-axis deformation to the point where the curve starts to become horizontal as shown in figure 1. This later point usually corresponds to the peak stability. However, as an alternative when the failure condition is not clearly defined, it can be selected at a point on the curve which is 6 flow point or 0.01 inches. Uh, Also 1.5 millimeters to the right of the tangent line. There is not ideal value, but there are acceptable limits. If flow at the selected optimum binder content is above the upper limit, the mix is considered too plastic or unstable, and if below the lower limit, is considered too brittle. The Marshall stability and flow test results are applicable to dense graded asphalt mixture with maximum size area up to 1 inch or 25 millimeter in size for the purpose of mixed design. Marshall stability and flow test result should consist of the average of minimum of 3 specimens at each increase of binder content, where the binder content varies in 0.5% increase over the range of binder content. The binder content range is generally selected on the basis of experience and historical testing data. Well, what is that? Data of the component materials, but may involve trial and error to include the desirable range of mixed properties. Dense grade mixture will generally show a peak in the stability within the range of binder content tested. Stability, flow, density, air voids, and void filled with asphalt binder may be plotted against binder content to allow selection of the optimum binder content for the mixture. The above test properties may also be weighted differently to reflect a particular mix design philosophy. In addition, a mixture design may be required to meet minimum voids in the minerals aggregate based on nominal maximum aggregate size in the mixture. Field laboratory margin, stability and flow test on specimen made with plant mixed laboratory compacted, also called PMLC. Asphalt mixture mix may vary significantly for laboratory design values because of difference in plant mixing versus laboratory mix. This includes mixing efficiency and again agents. Significant difference in Marshall stability and flow from the set of the test to another or from an average value of sets of data of specimens prepared from plant produce. Mix may indicate poor sampling, incorrect testing techniques, change of reading, change of binder content, or the malfunction of the plant process. The source of the variation should be resolved and the problem corrected. Specimens will most often be prepared using practice methods of Marshal, but may be prepared using other types of compensation producer, as long as specimens safety geometry requirements, other type of compensation may cause specimen to have different stress strain characteristics than specimen prepared by Marshal impact uh, compactation. Marshal stability and flow may be also be determined using filed cores from in situ payment for information or evaluation. However, this result may not compare with the result from mixed lab compacted, or in other words, with the decided in the laboratory. Asphalt mixture, plant mixture, well. Asphalt mixture specimens and shall not be used for specification or acceptance purpose. One source of error in testing filed cores arises. Approach breaking head, the testing head should consist of upper and lower cylindrical segment of cast gray or ductile iron, cast steel, or annulate steel tubing. The lower segment should be mounted on the base, having two perpendicular guides rods or posts minimum half inch in the diameters. Extending upward guide sleeves in the upper segment should direct to two segments together without appreciable binding or loose motion of the guide rod. A circular test heading with inside bevel having dimensions other than specified in figure 2 has been shown to give a result different from the standard testing head. Compression loading machine. The compression loading machine may consist of a screw jack mounted in the testing frame and should be designed to load at the uniform vertical movement of 2-inch. The design in figure 3 showed power being supplied by an electric engine or motor, a mechanical or hydraulic compression testing machine may also be used provided the rate of loading can be maintained at 2 inch per minute. Load measuring device as a minimum a calibrated nominal 20 kilonewtons ring diameters showed in the figure 3 with a dial indicator to measure ring deflections for applied loads is required. The 20 kilonewton ring should have a minimum sensitivity of 50 newton. The dial indicator should be gradated in increments of 0.0025 millimeters in final. The ring dynamometer should be attached to the testing frame, and adapter should be provided to transmit load to the braking head. The ring dynamometer ensemble may be replaced with a load cell connected to, to a load deformation record of computer provide capacity and sensitivity meet above requirements. Flow meters. The Marshal flow meter consists of the guide, sleeve, and a gauge. The active activating pin of the gauge shaft slide inside the guide sleeve with minimal friction, and the guide sleeve the point of frictional resistance shall be checked before test. Gradation of the flow meter gauge should be in increments or thinner. Instead of the flow meter, other devices such as an indicator dial of linear variable differential transducer connected to a low deformation record of or computer may be used. This alternate device should be capable of indicating or displaying flow deformation to the required sensitivity. This device must be designed to measure and record in the same relative movement between the top of the guide post and the upper braking head. Well, that's all for the podcast for today.